Hello students, in this class we shall discuss projectile motion. Next topic of our chapter kinematics. Okay, projectile so what is a projectile? First of all, projectile is an object that is thrown with some angle with respect to the horizontal, okay, near the surface of the earth. Like this is a typical projectile motion. If you throw something with this velocity in this direction, it will go like this and drop like this. This is called projectile motion. Okay. Now this is y-axis, this is x-axis. Let us suppose initial velocity of the projectile be u. It is projected with some initial velocity u, and it is projected also with some initial angle theta. Okay. Now what are the factors coming here? One factor is what is the time taken by the body to reach at this point, at the end point. That is called time of flight. Time of flight. Let it be t. Another factor is what is the distance traveled by the body in horizontal direction. This is called range or horizontal range. Or simply you can also call it range. It is denoted as h. Another factor is what will be the maximum height covered by the body. This distance is called maximum height. This distance range is actually not h, it is r, capital R. So this is range. Maximum height is another factor. Okay. Now we shall derive one by one all these factors, all these quantities. So first is time of flight. What will be the expression for time of flight? Now look, time of flight is the time taken by the body to reach from this point to this point. I will not take total path of the body into consideration. I will only take this to this, because time taken by the body to reach from this point to this point is equal to time taken by the body to reach from this point to this point. If you can find the time difference between these 2 points, then this is also equal, so total will be double. So let the time taken by the body to reach from this point to this point be t half. T half. Okay. Then what is the value of t half? So first resolve this u in two directions. One is vertical, another one is horizontal. So how to resolve it? U is like this. If you resolve it in a vertical and horizontal direction velocity will be u cos theta. Vertical will be u sin theta. Now I want to find out the time taken by the body to reach from this point to this point. That means if I go in horizontal direction, I will be reaching here. If I go in vertical direction, I will be reaching here. Okay, because its x component is along this path and it is the final point. and y component is along this part, and this is the final component. So I can choose any one component and simply I can find out the time taken by the body. If the particle goes with velocity u, with starting velocity u in this path, the time taken will be t half to reach at this point. If the particle goes in this direction with velocity u sin theta and it reaches at this top point, then also the time taken is also t half. If the particle goes in this direction with u cos theta, then also the time taken to reach at this point is t half. That means I can choose any of the velocities. So for simplicity, I will choose this movement, that is vertical direction motion. So now one thing you mark here, the particle is going like this. At this point its velocity is completely horizontal, because after that it is going down. That means vertical component at this point is 0. That means velocity at this point is 0. 0 velocity. Okay, that means vertically it starts with u sin theta but reaches at 0 velocity. So my final velocity is 0. Initial velocity is u sin theta. If it is moving up, that means acceleration is nothing but minus g. Then v is equal to u plus at. This implies v is 0, u is u sin theta minus g t half, because time taken by the body is t half. This implies t half is equal to u sin theta by g. If t half is this much, then what is total time taken? So t will be 2 times t half, that is equal to 2u sin theta by g. So this is the time of flight of the body. Okay. Now one factor is over. Next is horizontal range. So we have to remember it. Time taken t we have got. So t is equal to 2u sin theta by g. Now next is range. Now again I am coming to the resolution of u. First of all, I am going in horizontal direction. That means I have nothing to do with this u sin theta. Everything will be in horizontal direction. So if this direction velocity is u cos theta, then now let me write it. U is equal to u cos theta, because starting velocity is u cos theta. I don't know what is the final velocity, but what is acceleration in this direction? In horizontal direction, acceleration due to gravity does not act at all, because acceleration due to gravity is always in vertical direction. If you go downward, it is positive, that is 9.8. If you go upward, it will be minus 9.8. But what is the value in horizontal direction? Nothing, 0. That means in horizontal direction, acceleration is 0. If acceleration is 0, then velocity will never change. That means this is a constant. If this is constant throughout the travel, then what is the distance covered by the body? So we shall simply put that distance is equal to time into velocity, because this is constant velocity. So distance is nothing but r. What is the time? Time we have already found. total time taken by the body is 2u sin theta by g. So 2u sin theta by g into time already written. So what is velocity? Velocity is u cos theta. U cos theta. Now what is the value? U square 2 sin theta cos theta by g. Then 2 sin theta cos theta is nothing but sin 2 theta. This implies R is equal to u square sin 2 theta by g. This is formula for range. Okay. Now range we have got. Okay, where to write? Okay, forget it. We have already got it, so remember it. Okay, I am writing here. R is equal to u square sin 2 theta by g. Then last one is our maximum height. What is the maximum height covered by the body? That means this time I will be only considering this vertical motion, not horizontal motion. So next is maximum height. So this is okay. Now if you consider this vertical motion only, obviously final velocity is 0, initial velocity is u sin theta, and time taken also we know it, but we want distance traveled by the body in vertical direction. So which equation will be suitable for us? It will be v square is equal to u square plus 2as. So we shall put v square is equal to u square plus 2as. 2as or 2ax, it is x, implies v is 0, so 0, u is u sin theta, so u sin theta whole square plus 2 vertical direction acceleration is minus g, x is h. So what will be the expression for h? So h will be u square sin square theta by 2g. This is the expression for maximum height attained by the body. So these are the three questions relating to projectile motion. Okay. And these are the three quantities that you have to derive, and all the problems regarding this topic will be from these three quantities only. Okay, thank you.